Hello everyone, we will start our new chapter. Chapter 5 is about electron configuration. We will discuss two things in this chapter. We will discuss models of the atom and how to place electrons in atomic structure. So let's get started. First, when we start discussing about the atom, we say Dalton started with the atomic structure theory, and he said atoms are tiny indestructible particles with no internal structure. So he was thinking atoms as a like bowling ball kind of solid structure. Then J.J. Thomson did an experiment. His experiment was cathode ray tube, and he discovers the electrons there. Now he knows that there are some negative particles in the atom that is called electrons, and positive particles should be everywhere that is balancing the negative charge. After J.J. Thomson, Ernest Rutherford did a gold foil experiment. Remember gold foil experiment? Because of this experiment, he got the Nobel Prize. And with his gold foil experiment, he noticed that most of the alpha particles pass through. So he said, okay, there should be lots of empty space in the atomic structure. There's a dense positive nucleus with the protons in it, and electrons should be constantly spinning around. But he didn't say exactly where these electrons are spinning. So the problem with the Rutherford model is he couldn't explain the chemical properties. He couldn't explain the chemical properties of elements. For example, when you are heating elements, they change color, right? For example, you heat the metal, it changes like white, yellow, orange color. He couldn't explain it. What makes the elements change color? And all elements give off different colors when you heat them. What is the reason behind it? He couldn't explain. Then the scientists keep asking questions. We have Niels Bohr. Niels Bohr said, his experiment is about heating the elements. He heats the elements, and each time he heats the elements, he observes different colors. Then he said, okay, there should be fixed places for electrons. And when you heat the element, electron gain energy. When it cools down, it goes back to original energy level, and then it gives off the different energy as a light. That is why we see the color change when you see the element, when you heat the elements. His idea was very accurate actually. Yes, electrons are spinning at certain levels. It is like the Saturn ring. They are spinning at certain levels, and when you heat them, they gain energy, and when they go back, they release this energy as a light. So this model is very accurate. After Bohr model, scientists keep asking questions about the location of electrons. Now they understand that the nucleus, which is center of the atom, has protons and neutrons. Neutrons has no charge, protons has positive charge. And they said the electrons are not actually making a spin, but they are making different shapes while they are constantly moving around the atom. And they said there is a probable area, there is a most possible location to find the electrons there. And these are called orbitals. Let's go and discuss this part. So what Bohr said, electrons are only found specific circular paths or orbits. And that is, as you heat the electron, it jumps to the other energy level. When they go back to original energy level, so this is called, N1 is called ground level, okay? It is called ground level. When you heat this up, it jumps to the excited state, and when it cools down, it gives the energy as a light. We see it as a light, as a different color. That is Bohr model. And according to his model, electrons are spinning around the orbit, okay? And electrons has fixed energy level. You may want to write this down. Electrons, they have fixed energy level, okay? And each electron can gain quantum of energy, which is a certain energy level, which is a fixed energy level. And what he noticed is the energy levels are not the same. It is like this strange ladder. The energy levels are not equal in the atom. So our current model that we accept today is called quantum mechanical model. In the regions, they are going to use it as a wave mechanical model. Okay, that is the last accepted model for the atom. What does this say? It says the electron cloud of an atom is compared here to photographs of a spinning airplane propeller. You know that propellers are there, but they are spinning very fast, and they make a cloud like shape, and electrons act similar way. There is a possible place you can locate it. It's in this area, but you don't know exactly where. That is what wave mechanical model says. And this area is called, this possible cloud area is called atomic orbital. It's called atomic orbital. They ask every year, they ask a question: what is orbital? It is it's a region of a place. So it's a high probability of finding an electron. It is a space in which there is a high probability of finding an electron. Okay, that's the meaning of orbital. It is the area you can find the electrons. You don't know exactly where, like these propellers, but you know it is in there. It is the most possible area, and it is called atomic orbital. You may want to write it down. So we will discuss, they don't have a certain shape. They are making different shapes. I'm going to show you how they act. For example, different atomic orbitals are denoted by letters. For example, S orbitals are spherical, which means electrons are spinning around the nucleus in a spherical shape. P orbitals are dumbbell shape. Look at this: X, Y, and Z coordinates. Electron can go like this. It can go like this in Y coordinates, or it can go like Z coordinates. Okay? We have more orbitals. There are many different shapes to find the electrons. These are called D orbitals. We have 5 different D orbitals based on the motion of electrons. It can go XY direction, XZ direction, YZ direction, between Y and Z, and also with Z direction with a ring in it. Right? These are all D orbitals. Now, these are just extra ideas to visualize the shapes of orbitals. You don't need to worry about this, but you need to understand different energy levels have different sub-levels. Okay, here I'm gonna show it here. So first energy level, second energy level, third energy level. For each energy level, there are different sub-levels. Okay, and for different sub-levels, there's a formula to calculate. I'm going to show you this formula. There's a formula to calculate. In the first energy level, you can only put one s orbital. Second energy level, you can put two sublevels, and you can put 4 orbitals, 2s and 2p. And remember, p have 3 different shapes, px, py, and pz. That is why we said there are 4 different orbitals in the second energy level. Third energy level, look at this, you have 1, 3, and 5, total 9. Fourth energy level, you have 1, 3, 5, 7. I think you got the idea here, right? You got the idea here. I'm going to show the formula when we take notes, but you can also see here. It is 2 to the power 1. 2 times 2 to the power, I think you got this one. This is the maximum number of electrons you can place in the orbitals. I'm going to stop here. We will continue the next part later. Bye everyone.